So today we will see a new method for solving systems of linear equations. Today we are going to see the one that it's called matching or equalization method. The idea of this one is very similar to substitution because we will need to isolate a variable, but we will isolate the same variable in both equations, not only on one. So after isolating the same variable in both equations, we can equalize both isolated equations. That means the answer of the first variable will come from that new equation that we have created by isolating the same variable on both equations. As always, if we are doing the verification process in this kind of exercises, we must do it on both original equations. So let's see. I will isolate x in both equations. We can isolate the letter you want. It's going to be 6x equals minus 9 plus 5y. X equals minus 9 plus 5y. All of it divided by 6. The other one is going to be 4x equals 13 minus 3y. X equals, and it's going to be 13 minus 3y, all of it divided by 4. So we have already isolated x on both equations, so we can match or equalize both equations, and it's going to be minus 9 plus 5y, all of it divided by 6 equals 13 minus 3y, all of it divided by 4. So it's going to be 4 that multiplies minus 9 plus 5y equals 6 that multiplies 13 minus 3y. It's going to be minus 36 plus 45y. I'm sorry, not plus 45. It's going to be plus 20 plus 20y equals, it's going to be 78 minus 18y. So it's going to be 20y plus 18y equals, and it's going to be 78 plus 36, 38y equals, and it's going to be 78 plus 36, 114. Y equals 114 over 38. 38 multiplied by 3, it's 114, so y equals 3. So when we have the value of y, we can use any of the original equations to get the value of x. I will use the first one. It's going to be 6x minus 5 that multiplies y equals minus 9. 6x minus 15 equals minus 9. 6x equals minus 9 plus 15. 6x equals 6. X equals 6 over 6. That means x equals 1. So we have the independent value of the answer. X equals 1, y comma 3. We can put it in coordinates. Remember, in coordinates it's first the x, then the y. So it's going to be 1 comma 3. And if we want to represent that in a graphic, it's going to be x 1 positive, y 3 positive. So it's going to be exactly this point. So that will be the process for solving this matching or equalization method. Let me do the verification process only in this first example. So we have that the answer is x equals 1 and y equals 3. So let's see. On the first equation, it's going to be 6 that multiplies 1 minus 5 that multiplies 3 equals minus 9. 6 minus 15 equals minus 9. Minus 9 equals minus 9. So it's okay. Let's check on the second one. 4 that multiplies 1 plus 3 that multiplies 3 equals 13. 4 plus 9 equals 13. 13 equals 13. So we have done correctly the verification process of the answers of this exercise. So verification process, it doesn't matter the method, it's always the same, substituting the correct answer or the answers in the original equations. Let's see other example of matching or equalization method. So let's see, remember we need to isolate the same variable in both equations. I will isolate the x on both equations, and it's going to be 11x equals 2 plus 9y. That will mean x equals 2 plus 9y over 11. So we have already isolated the x. We need to do the same on the second equation. It's going to be 13x equals minus 2 plus 15y. X equals, and it's going to be minus 2 plus 15y, all of it divided by 13. After having the same letter isolated, remember we need to match our equations, and it's going to be 2 plus 9 divided by 9y, divided by 11 equals minus 2 plus 15y, all of it divided by 13. So it's going to be 13 that multiplies 2 plus 9y equals 11 that multiplies minus 2 plus 15y. It's going to be 13 times 2, it's 26, plus 117y equals minus 22, plus, and it's going to be 15 times 11. 15 times 11 is going to be 165y. So it's going to be 117y minus 165y equals minus 22 minus 26. So it's going to be minus 48, and it's going to be 165 minus 117. It's going to be 48y. Y equals minus 48 divided by 48. That means y equals minus 1. So we have already the value of y. Let's see the value of x. Remember, we need to use an original equation to know the value of x. Or we can do it also in one of these equations. It's up to you. So if you want to do it in one of those equations, it's going to be x equals minus 2 plus 15. That multiplies y, all of it divided by 13. It's going to be x equals minus 2 minus 15, all of it divided by 13. Here we have a little problem. It was a mistake maybe. Here it's minus 48, so it will be minus 48 here, and it will be, a plus here. Y equals plus 1. So here it's going to be plus 1, here it's going to be plus 15. It's going to be x equals 13 divided by 13. X equals 1. I'm sorry for this mistake. So it's going to be 1 comma 1. If we want to put it in coordinates, x comma y, that it's 1 comma 1. And if we want to put it in the axis, it's going to be x1, y1. So this is the exact point that the answer represents. So it's not difficult to do the matching or equalization method. The idea is to isolate the variable in both equations. After that, we will match the equations, we will solve them, and after that we will be able to know the other variable a specific value by substituting in the original equation or in the isolated equations. Let's see one last example. So let's see, imagine we have this system of equations. Of course, first we need to simplify our equations in order to have them as a normal equation and isolate the same variable on both equations. Since on the second one, I can already isolate the y because it's going to be very simple. All of it divided by y, by 2, I'm sorry, by 2 equals y. So I have already isolated the y on the second equation. I will isolate the y on the first equation. Let's see, it's going to be 6 minus 8x plus 4y minus 4 equals x minus 6 minus multiplied by minus, it's plus 3y. It's going to be minus 8x plus 4y plus 2 equals x plus 3y minus 6. So it's going to be minus 9x. Well, I will do it in steps for explanation purposes. Minus 8x minus x plus 4y minus 3y equals, and it's going to be minus 6 minus 2 minus 9x plus y equals minus 8, y equals minus 8 plus 9x. So after having isolated the y on both equations, I can match both equations, and it's going to be 9x plus 1 divided by 2 equals minus 8 plus 9x. So it's going to be 9x plus 1 equals 2 that multiplies minus 8 plus 9x. 9x plus 1 equals minus 16 plus 18x. It's going to be 9x minus 18x equals minus 16 minus 1. It's going to be minus 9x equals minus 17. X equals minus 17 over minus 9. That means x equals 17 over 9. We have already the value of x. We need to use it in another equations to get the value of y. I will use this one. So it's going to be 9 that multiplies x, that is 17 over 9, plus 1, all of it divided by 2 equals y. 9 over 9, so it's going to be 17 plus 1, all of it divided by 2 equals y. 18 divided by 2 equals y. That means y equals 9. So we have already a value of x and y. If we want to put it in coordinates, remember it's parentheses x comma y. So it's going to be 17 over 9 comma 9. And that will be the answer in coordinates. So the matching or equalization method, it's very common. It's very similar to the isolation method, but remember, we need to isolate the same variable on both equations. You decide which equation, or I mean, which variable you want to isolate. After that, we will match those equations. We will solve it for that specific letter. And after that, we will substitute the value in one of the equations to get the value of the other letter. That will be it for today's topic. See you on the next video. That will be the next method for solving systems of linear equations.